All right, well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm up 74 is on your screen. By now, you should be able to do that one in no time. I'll give you like 4 minutes. Copy and go. All right. Our agenda for today, warm up number 74, log functions. Today, I'm not leaving you any home play, so you can have the weekend to rest because I know state exams are coming up and finals are coming up next week. So like that gives you time to refresh and be ready for all of that. So once again, warm up 74, log functions, and no home play. There is no asynchronous code as well. So like that, you are to just chillax. Those of you that need to finish up some stuff from your other classes, because I'm pretty sure you're all caught up with me. Bam, let's go. All right, your previous home play was play sheet 16.1. Go to Canvas, turn that in right now, please. Numbers 1 through 12. I'll give you some time for that, and then we'll get started. You get a Cornell note ready. All right, here we go. I can simplify log functions. I can simplify logarithmic functions. So we already know what logs are. They are the inverse of exponentials. We went from logarithmic to exponential and vice versa. We covered some definitions. We did the product property of logs. We did some problems to practice that. We did quotient property of logs. We also did a couple of those, which brings us to this one. Copy this. Power property of logarithms. We got log base b for the given number m to the n exponent, and that becomes n log b for the given number n. All right. All right, so let's do one of these to make sure we got the process. Copy this one, example 3. It says, express each expression in a single logarithm. Simplifies if possible. So they give us log base 4 for the given number 64 to the third power. All right. Here we go. So according to the power property of logs, whenever you are given a log to whatever base in a given number, to get started, you take the exponent on the given number and send it to the front as a leading coefficient or as a coefficient. So we write it as 3, and then we write log base 4, and that leaves us with 64. From there, we rewrite this again. We got 3 log base 4, and the 64, we're going to write it in base 4. That's 16. That's 4 and 4, so that's 4 to the third power. Now, according to the definition that we covered the other day, we said that if these two have the same base, the answer is what? The exponent. So that means I bring this one down. That's 3. But since we have the original exponent over here, I'm going to bring this one down, multiply times that. So my answer is 9. Very simple. Yes, Mr. Q. So basically you take the exponent, move it to the front, simplify the number in the same base, and then get the exponent and multiply times the original exponent. Okay, let's do another one. Example 3Q. Copy this one. Log base 3, number 81, and to the 5th power. All right. So here we go. So we're going to take the exponent and move it to the front. So this is 5 log base 3, 81. We rewrite it once again, 5 log base 3, and 81 in base 3, that's 27, in base 3, that's 9, in base 3, that's 3. So that's 4 of them, so that's 3 to the 4th power. Once again, according to our definition, if these have the same base, the answer is what? 4. However, we have a original exponent, which was 5, so this is 20. Piece of cake, yeah? Yes, Mr. Q. All right. I'm going to give you another one, see if you can do this next one by yourself. Example 3 super Q. Example 3 super Q, we got log base 2, given number 64 to the 6th power. I'll give you a head start. Log base 2, given number 64 to the 6th power. Okay, should be just about done. All right. Angie, what'd you get?
36.
36. That is correct. So this becomes 6 log 2, 64, 6 log 2, 64 to the base 2, that's 32, base 2, that's 16, base 2, that's 8, base 2, that's 4, base 2, that's 2, that's 6 of them, so that's 2 to the 6th power. Once again, this is the same as this, so the answer for that is 6. But we have our other exponent, 6 times 6, that's 36. There it is. And one last one. Copy this one. Example 3 mega cube. Log base 6, and we got 36 to the 7th power. All right, what'd you get for this one? Victor.
Oh, you're going too quick for me, Mr. Q.
What? Mia, what'd you get?
14.
14 is correct. All right, so we're done with that one. Let's move on to the next property. Copy this. Change of base property of logs. Logs, we got log base C given number A becomes log base B given number A over log base B given number C. All right. So let's see it with numbers. Ready? Here we go. Copy that. Example 4. All right. So according to the change of base property, whenever you are given a log like this one, and notice that the bases are different. Okay, so then this becomes log 3 divided by log 2. And what that does, that gives us an opportunity to compute this on our handy dandy calculator. Let me get that in front of me. We got log 3 divided by log base 2. And that gives us approximately 1.584962501. I'm going to simplify that to 1.59. 1.59. 1.59. Because if you notice on the other ones, we were able to get a number because of the processes, and we multiplied numbers, and at the end we would end up with a number. In this case, since they are totally different bases, we need to use a calculator to calculate the value of that log. Let's do another one. Example 4Q, we got log base 5 to find number 7. Log base 5 to find number 7. All right. So we got log 7 over log 5. So if I go to Desmos, get my handy dandy calculator, I got 7, and I got divided by log 5. That gives me approximately 1.209061955. I'm going to round it up to 1.21. 1.21. Now, how did I get there? For those of you that are probably looking at this, you go to Desmos.com, select the scientific calculator, and in there you go here on the tabs, you go to functions, go to log, and then go back to the main and type in whatever the number. So it was 7. Then you do divided by, and then again go to functions, go to log, go back to the main. What was the number? Was it 2, 5? What was it? 5? Yeah, 5.
Yeah, that's fine.
Yeah, so then 5. And it should give you the number right there. Okay. And there it is. Woo, let's go. So let's see. Logs. Have we transformed logs? Have we graphed logs? Have we solved for logs? Yes, Mr. Q. Have we simplified, defined? Yes. And lastly, what did we do with logs for these couple of sessions that we covered? We covered definitions of logs. Yes. We covered product property and quotient property of logs. And today we covered power property of logs and change of base property of logs. We good? Yeah? Yes, Mr. Q. So did we simplify log functions? Yes. So that's going to be our last session of Algebra 2. You're like, what? Ain't that crazy? Yeah, time flew. Time flew, and it went pretty fast. But good thing you guys stayed focused and concentrated, right? And for those of you that forgot, maybe for next time, just make sure you drink a lot of apple juice and orange juice, right? Why, Victor?
You need to remind me again, Mr. Q.
What? Because we're made out of concentrate. My goodness.
I see. There it is. There it is. I remember now.
All right, guys. So don't leave yet. I'm just gonna stop the video so that I can upload this in a little bit. All right. Give me a second. And once again, no home plate today. All right. So have a great weekend, and I'll see you guys pretty soon. Peace. Bye.